a small pause just to think about why we're developing models. What you see behind me is Ptolemy's model. I mean, those epicycles, equant, and it doesn't represent everything. And the question is, why do we need to worry about all this? Why would even people, well, you might think that they are mad people, but are trying to actually go to extra lengths to try to explain what they observe? Okay, fine, it's right there in the sky. It doesn't affect anything we're doing. Now, uh, just before I actually try to explain why people would go to develop models, think about the fact that trying to understand the world around us actually led to present day technologies and science, which actually achieved a lot of things that are actually contributing to your comfort, to studying at home also through the internet, which you probably don't like a lot. But basically, it did provide a lot of tools that are interesting, be it communications through social media, your smartphone, a lot of things. And all this started from that, from trying to make sense of the world around us. You'd say, okay, fine. I mean, maybe it might be interesting to make sense of rain, thunder, storms, etc. Why do we want to make sense of the universe? Well, because we have an inquisitive mind, but also because, and that's a small parenthesis, if you'd like, people thought that that the motion would represent what they were made for. So trying to search for a sense of where we are. And it's also similar to trying to understand storms and things like that. It's actually trying to get predictability. So you'd like to be able to predict. You'd like to be able to know ahead of time what's coming. And at some point, kings and uh, uh, important people, princes, generals, probably at the time, you had battles, you had things like that, and you wanted to predict ahead of time if you're going to win. And they used to think, because as we've seen that the choice between geocentricity and heliocentricity was a purely philosophical choice, there was nothing to decide for one and the other. The view of the heavens was a view of perfection. That's why you see circles everywhere. The other thing that I want to tell you is that when Ptolemy did his model with the epicycles, it was not just retrograde motion we're trying to explain. I mean, there are a lot of things that we didn't talk about. You might have noticed them while doing your stellarium simulation, like, for example, the fact that it seemed that the brightness of the object, or the point that represented the object, be it Mars or Mercury, actually didn't have always the same brightness. So people did see that. That was observable in the sky. People did see that the brightness of the stars that they called planets, which were actually moving relative to the other stars, were actually dimming and increasing in brightness. But we didn't go into all these effects. A continuous observation of the sky would show you a lot of measurements of these motion, would show you a lot of other things we don't talk about. The purpose of it is not to actually have a detailed knowledge of what's happening in the sky. The whole idea is to understand first a general view of how did they build the model, how did they determine this or that particular understanding of the earth, the motion of the earth, the motion of the sky, and how that kind of argument, logical argument, led to our current understanding and current achievements in terms of science and understanding the solar system. So people were searching for predictability. And when they actually built up those complex systems, they were trying to explain everything they used to observe. But when I say everything, it's really everything. The small details, the observations of how fast a planet was in the sky. So, I mean, you see it moving, but we didn't talk about its speed. How fast it was moving was something they were trying to explain. And that's why you see Ptolemy, for example, going to those complex things like equant and different, and the Earth is slightly away, etc. And the whole history that went after Ptolemy in 150 AD was all about making sure that the model, that the way we conceive of the world, that the way we actually build an apparatus, if you'd like, a mechanical apparatus to try to predict the position of objects and their brightnesses, etc., was as accurate as possible. So this was basically just the parenthesis open. Some of you might listen to this video, some will not. But I just wanted to frame again things of why people were concerned about models before we jump forward. Let's not forget that building models and searching for predictability, for being able to predict ahead of time what's going to happen, and making sure that your model is accurate, is what led to a rover being sent to Mars and satellites and orbiters being sent to Mars and actually behaving in exactly the way we expected them to behave, although we were not in control, in the sense that we've computed all the model initially, and they actually reached the planet at the point we expect them to reach. The whole system behaved in exactly the same way we expected to behave, thanks to those models we have that explain the world around us. Okay, so let's go back now and continue the story of what led to heliocentricity.